We looked at the copy routine together. Now it's time for you to do the programming. So let's open up 1.5.3, implementing routine that scales a vector. So we get a new notebook, this time one that describes how to scale a vector. Now remember, the first thing we're going to do is to make a copy, and then we're ready to start editing this. I'll let you read the text yourself, and instead we go straight for the first executable cell, and we do exactly what we did before, which is we import numpy, and then we create a vector x as a matrix with only one column. And this time we create a scalar alpha, which we set to 2.5, which is kind of arbitrary. So let's execute that box. And bingo, we've got ourselves a vector. We're going to scale the vector x in a couple of different ways. So it's convenient to create a vector x old into which we copy our vector x so that we have a copy of it, so that we can restore our vector x as we do our different experiments. And notice that for this copy, we use the routine from the LAF library that we described when we described the last notebook. So let's execute that. And now we have a vector x old. And if we now want to scale vector x, one way in which we can do this is to simply use native Python to do this. And all we have to say is alpha times x. The star there means times. And if we execute that particular box, then indeed we have a vector x as it was originally, 1, 2, 3. And after scaling it becomes 2.5, 5, 7.5. So that works gloriously. Now, the whole purpose of this course, though, is to teach you a little bit about programming and to do this ourselves as opposed to depending too much on Python, because that way you get to relate the mathematics to how one may want to program this up. So we're going to do the scaling with a loop. And in this particular case, the vector x we know is of size 3. For your convenience, I've repeated here the loop that copies a vector of size 3 into a vector y. In this executable cell, the first thing we do is we copy the vector x old into x that restores x to the vector 1, 2, 3. I want you to write a loop here that scales each individual entry of x by alpha. So I'm going to take a break. You're going to pause this, and then when you're ready to go on, you're going to continue this video, and we'll discuss how to do this together. All right, now I'm back. Let's see what we should insert here. I'm a great believer in cutting and pasting. So, since this loop is up here, let's cut and paste it into where we need to insert it. And let's rearrange this because that needs to be like that. Now this is the loop that copies a vector of size 3 into another vector. What we instead want to do is scale the individual entries of the vector x. So all we do is we multiply the individual entries by alpha, and with a little bit of luck, this actually works. So if we execute it, we get the vector x before scaling, 1, 2, 3. After scaling, 2.5, 5, 7.5. And if we check the difference between that and alpha times the old vector, we get 0, which is what we want. Congratulations, you wrote a very nice loop. If we now want to do this as a routine, then we want to instead define a scale routine. Okay, so I've done some of the work for you here. I've defined a routine called scale, and I've extracted already the sizes of the matrix x. Remember, the vector is stored as a matrix. I want you to insert the loop that will scale the individual entries of x right there. All right, so I'll take a break again. You pause this video. When you're ready to go on, simply restart the video. It'll continue, and then I'll discuss how to do this with you. Okay, I'm gonna get some coffee. You do your programming. go on. Let's have a look. Well, again, I'm a great believer in cutting and pasting, and we wrote a loop earlier that scales a vector of size 3. So surely that must be pretty close to what we need. So I'll cut and paste that. I'll put it right in here. And I need to indent this, so I use the tab. And the only catch here is that I don't want to do this in the range from 0 to 3, not including 3. Instead, I want to do this in the range from 0 to m, not including m. If I now execute this box, then we have this as a routine. And to test this now, we execute this cell right here. We first copy xold back into x, and then we call our scale routine. And lo and behold, everything is good. Now, as part of the laugh library, there is a routine called scale as well. So if you import laugh as laugh, then you can call the routine laugh.scale to accomplish exactly what we just discussed, except that for this particular routine, x can be either a row or a column vector, and that's going to become very important later on as we start looking at more complicated operations. Now, if you really need a challenge, then go back to this much more complete copy routine that was given in the notebook for section 1.5.2, and go ahead and try to implement a scale routine that does parameter checking and that works for the case where x is a row vector or a column vector.